I'm Ian McKenzie, Director of the Aviation Program here at the University of Waterloo, and I'll be your MC for this exciting event today. The format for today's program includes an opportunity to hear a presentation from Canadian Space Agency astronaut Jeremy Hansen, followed by a presentation from Dr. Richard Hewson from the Faculty of Applied Health Sciences, and then we'll go to President Ferdinand Handel to welcome Chris Hadfield to the University of Waterloo. Following that, we'll go into an immediate program of questions from the University of Waterloo students. All 6 of the University of Waterloo faculties are represented here today. The faculties of Applied Health Sciences, Arts, Engineering, Environment, Mathematics, and Science. Immediately following the downlink event, astronaut Jeremy Hansen will take questions from the audience after the downlink. I'd like to take this opportunity to welcome all of the distinguished guests that we have here today, and following that, I'm going to move directly into introducing our first speaker, astronaut Jeremy Hansen. Jeremy Hansen was born in London, Ontario, raised in Elsie Craig, and finished high school in nearby Ingersoll. He is a graduate of the RMC Royal Military College program. He earned a Bachelor of Science in Space Science and followed that with a Master of Science in Physics. His research topic in physics was wide field of view satellite tracking. He's been a member of the Canadian Armed Forces since 1994, and prior to joining the Canadian Space Program, he was a CF-18 fighter pilot. He took his first flight training at the age of 12 when he joined the Canadian Air Cadet Program, and he earned his glider's pilot's license and his private pilot's license before the age of 17. He moved on to continue to develop his aviation career through the Canadian military, and in 2009, in May of 2009, he was selected to be one of the Canadian astronauts to join the Canadian Astronaut Program. In 2011, he graduated from the NASA space class, and he was in the 20th NASA astronaut class, one of only 14 members of that class. Since his graduation, and now with the Canadian Space Agency, he's been acting as crew support astronaut to Chris Hadfield aboard the International Space Station for Expedition 34 and 35. I'd please like to welcome astronaut Jeremy Hansen. Thank you.
Well, good morning, University of Waterloo. It's exciting for me to be home in Canada. I live in Houston, Texas now, so I'm always happy to make the trip back to Canada. Although I was commenting yesterday, I don't miss driving in the snowy roads, but I do miss Canada a great deal. So it felt like home arriving in Toronto and coming here yesterday. So a lot going on in space today. I thought I came here anticipating we would talk really only about Chris Hadfield's mission, but I thought this morning maybe we'd all benefit from a quick discussion on what's been in the news yesterday with respect to asteroids. It's somewhat interesting, I find. Later this afternoon, we're expecting an asteroid to pass close to our planet Earth. It's approximately a 45-meter diameter asteroid, so roughly the size of this room, if you will. And it's going to come relatively close, about 27,000 kilometers from Earth. That sounds like a long way away, but it's pretty close because all the satellites we use for communications, like if you want to watch satellite TV and you set up your dish outside to get Bell Express View, for example, you're pointing at a geostationary satellite, which is at 42,000 kilometers. So this asteroid is going to pass within that band of satellites and could potentially disrupt or hit one of those satellites. Probably won't. Space is big and the asteroid is relatively small. But much more threatening was what happened earlier this morning in Russia, where an asteroid actually did penetrate the Earth's atmosphere and injured a lot of people. And of course, news is still coming in. The latest I heard was maybe upwards of 1,000 people, getting close to 1,000 people have been reported as being injured this morning, mostly by broken glass. So everything I'm about to say is really quite sketchy. Of course, I don't know a lot of these answers, but I can kind of give you an idea of what I've heard so far. An object that would cause this kind of damage could be on the order of 20 meters in diameter. And its combination of density and size was not such that it could make it all the way to the surface of the planet and cause a crater, a huge crater and mass destruction. It apparently blew up at high altitude above the Earth. And most of the injuries were likely caused by the blast effect, the explosion of this object at high altitude and then breaking windows and flying glass. So what is the threat to the planet? I thought you might be interested in that. So nothing today is new. This isn't new news. People have known about this threat for a long time. The Earth's struck by objects all the time. In fact, about 100 tons of debris hits our planet every day. Most of it doesn't pose a threat to us. Obviously, objects of this size do. So for a long time, we've been starting to look at these asteroids in our solar system to try and get an appreciation for what are the odds that one of these would strike the Earth. And it was determined we should start looking for objects bigger than a kilometer. Because if you have something larger than a kilometer hit the Earth, it is going to make it to the surface, and it is going to be what we would call maybe an end-of-days disaster. It'll change the face of life on the planet for sure. It'll have a massive effect on the atmosphere, maybe our ability to grow crops, and would be a major Earth disaster. So it's considered that about 95% of those objects have been found in our solar system now and don't pose a significant threat to our planet in the near future. But what about the objects that we're talking about today, the ones that are smaller? Well, they're very difficult to track. Right now we're using ground-based telescopes to look for these asteroids in our solar system. But I thought it was relevant today. I wanted to tell you about this guy. In fact, just on the 25th of February, the Canadian Space Agency is launching this satellite. It's called NEOSat, and it's going to be the first spaceborne satellite that looks for near-Earth objects, asteroids. It'll also look for space junk and satellites in orbit, but it's going to be looking for asteroids as well, and it's going to allow us to look in chunks of the solar system that previously we've been unable to look in. So, for example, it can look much closer to the sun than an Earth-based telescope can look. So this is an exciting time when we get NEOSat up there, and it's going to help us see some of the smaller objects, but there's still a great number that we won't have tracked or maybe don't know about. And there's estimates that maybe there's somewhere between 100,000 and 1 million of these smaller asteroids that we haven't seen that are in Earth-crossing orbits. So we still have a lot to learn, but we're making progress. So what else are we going to talk about today? Well, the International Space Station. It, of course, was not safe from the asteroid that flew over Russia earlier this morning either. It would have crossed, roughly it certainly went through the altitude of the space station, which is 400 kilometers above our planet. But it's kind of exciting because we're going to be talking to Chris Hadfield on this station today, and I thought you might want to know a bit about the station. The station is pretty huge by our standards, from my perspective anyway. It's the size of a football field. And the astronauts live and work in these tin cans that are kind of lined up in a T. There's a T at the back here. And the volume of the space station is on the order of the size of the inside of a 747. That's how much space the astronauts have to work and live. And on any given day, or most days of the year, we have 6 astronauts on the International Space Station. And of course, right now, we have a Canadian, some precious Canadian cargo on the International Space Station, Chris Hadfield. So Chris has done all sorts of training with respect to the threat of asteroids or solar debris hitting the space station. In fact, we get peppered with debris all the time in the space station. As we watch the space station age, we get these little puck marks on the outside of the space station. When we're doing spacewalks, we have to be careful not to cut our gloves on these debris marks that are left on the station. But if one is large enough, it could penetrate the hull of the space station. And then Chris would be he's been trained to isolate that leak and then repair it if it's possible and safe to do so. So this is kind of a fun photo because Chris has included our Canadian flag, of course, but he's also in the cupola. And the cupola is a 360-degree window. So this pane of glass that's at the top, of course, is parallel with the surface of the planet most of the time, depending on how the station's flying. But then these other windows around the outside give Chris a 360-degree view of our planet and looking out into space, the blackness of space, a pretty amazing perspective. It's one of the things I look forward to as an astronaut, to have that perspective of gazing back on our planet from space. And Chris has been sharing that with us by sending us photos, and he was thinking of you guys yesterday, and this is kind of unique that he flew over this area just a day before he spoke with you, but he decided to take a picture of us here in Waterloo. So this is Lake Ontario, here's Hamilton, and here's Kitchener-Waterloo, and this is the conservation area over here, which pretty much would point to where you and I are sitting and standing respectively right now. How did Chris get there? Well, he launched on the 19th of December on a Russian Soyuz rocket, and this is a picture of Chris on the far side here in his actual vehicle that he launched in. It's still on the ground. This is the fit check a few days before launch. You can see the window here. There's a gentleman in the picture. You can make that out. And the picture was taken from outside the capsule, from the other window on the opposite side. And then here's the commander, the Russian commander, Roman Romanenko, and Tom Marshburn in the right seat of Soyuz. This is what it looked like when it took off on the 19th of December. And I was there in Kazakhstan to see the launch. What an amazing experience for me to witness the launch with Chris's family. Just it's so much power, and it's so emotional to see something like this. We were speaking with Chris in the morning, and we loaded him in the pointy end of this rocket, and we lit that thing, and zoom, he's gone. It's just amazing. And we could see it was so cold and so clear on the day of the launch. We could see the rocket. It was at nighttime. It was just before sunset. So we could see the rocket go all the way to orbit. It takes about 8.5 minutes to get there. And it just kept getting dimmer and dimmer like a star. And then eventually at 8.5 minutes, we saw the star just extinguish, and Chris was in orbit. So a pretty powerful experience for all of us there watching. And then he joined, 2 days later, he caught up with the space station and joined the rest of his crew. So we have, on here we have 3 Russians up here at the top, and then Kevin Ford, a US astronaut, and then of course Chris here in the front. And I love this picture of these guys because this is what I think of them. They're my friends. They're just great people. They're all just ordinary people like you and me. If you had the opportunity to sit down and have supper with them one night, you think, wow, what a great bunch of people. Just great human beings. And it's fun that they're bringing this experience back to Earth for us. Of course, what is Chris doing on the space station? Well, he's doing quite a bit. We're keeping him pretty busy. We schedule his days. They're full. We keep them awake 16 hours. And we give them, of course, a little bit of personal time during the week, especially on Saturdays and Sundays. Saturdays, they have about a half day of work. And Sundays, they have a bit of work to do, but not very much. So we do give them some time and space to look out the windows and ponder their existence, and things like that. But most of the time, we keep them busy. Here, Chris is working with Milfy, which is a minus 80-degree freezer, which, of course, we're using for research. Chris will spend about 2 hours of every day, including the weekends, exercising to stay fit in space. Because if you don't, with the lack of gravity, if you don't exercise, you come back, you're more like a jellyfish than a human. Your bones start to absorb back into your bloodstream. You end up urinating out your bone mass. Your muscles just get weak. And when you come back to Earth, you're not in shape to walk around. We've come a long way with respect to progress with exercise in space. And now astronauts are coming back with similar bone densities, not necessarily bone strength, but bone densities, and with muscle mass similar to when they launched. And this is important research because we're trying to understand. In the university, you're going to hear more about it this morning. This research is going to help us prepare to send people to other planets so that when they arrive there after long durations in space, they're in shape to actually survive on the surface of another planet. And this is just an example of what it looks like inside the space station. It's a pretty busy place. Of course, there's some package here. Everything has to be kept in these boxes or it floats around and gets lost. Some of the pictures Chris has been sending back, I love this photo because if you look here, you can see the extent of the Earth's atmosphere above our planet. That thin green band at the top really represents the edge of our atmosphere. And when you and I stand here and look up, look at airplanes, we think we have an infinite amount of atmosphere, but really when you look at it from Chris's perspective, you realize we're all on a spaceship already hurtling through space with just this tiny atmosphere that's keeping us alive with a water cycle, air to breathe, protection from the Earth or the sun's harmful radiation. When Chris's mission is over, he'll come back in his Soyuz capsule, just this little tiny thing underneath a parachute with his 2 crewmates. Why are we doing this? There's a lot of reasons for what we're doing with the International Space Station, international cooperation, all the science. But I just wanted to highlight this because this is a university crowd. I think this is applicable to you. Our goal is to send humanity to other planetary bodies in our solar system. That's what we're ultimately working towards. And what Chris is doing on Space Station, all of these things contribute to us understanding how to live and work in space and getting humanity to the surface of places like Mars in this picture. Times are changing, commercial spaceflight is taking hold, and for all of you here, is an exciting time if you want to be part of that. Canada could certainly use you in this field. So I'm looking forward to the questions this morning, the chat with Chris. It's always amazing to chat with someone who's 400 kilometers above the surface of our planet, traveling 28,000 kilometers an hour. It's a pretty cool experience. Dr. Houston?
Thank you very much, Major Hansen. We look forward to opportunities for questions from the audience after the downlink. Next, I would like to introduce our next presenter from the Faculty of Applied Health Sciences. He's also the holder of the Schlegel Research Chair in Vascular Aging and Brain Health. Please welcome Dr. Richard Houston.
Okay, thanks very much, Ian, and Jeremy. That was great to see the intro to what we're about to experience. I've been really fortunate in my research career here at Waterloo. First of all, from the perspective of the university, where they encourage you to just do what you want to do, as long as it's good science, good academic work. And so for the past 15 years, I've worked with the Canadian Space Agency and had the opportunity to work with the astronauts. Jeremy just mentioned, if you sit down at dinner with these guys. In Russia, we did some of these experiments in Russia, and we had a chance to do that. Because in Russia, there are only the few astronauts, and it was just fantastic sitting down and actually talking with them about the, what it was like to go through their training, and they really are just normal people. We've been doing 3 so far, and 1 more to come, experiments. I'll just really quickly go through these. I don't have a lot of time to talk about the science. It's just more a little bit of a show of, well, this is what you do when you do space research. So we did CSIS, an experiment that started in 2001, wrapped up in 2009 when Bob Thirsk landed. Chris is one of our last subjects for the Vascular experiment. Started in 2004, our first astronaut launched in 2009. It'll be finished by the end of 2013 in terms of data collection. BPRIG is a new experiment. Chris is our very first subject for it. And then we have 1 other experiment, which hopefully will get started this year and we'll have some astronauts relatively soon. Oops. Okay. Waterloo involvement. Well, this has just been fantastic for us, and absolutely, there's no way I could have done it without Danielle Greaves, who's sitting down here. Danielle has been the mainstay behind all of the details that go on, and is just a fantastic person in the lab as well. And my grad students and postdocs who were able to be involved. Catherine, you can see Catherine up here with Anna. One of our first times down in Kennedy Space Center, that's the door the astronauts walk out of, and they wave to the crowd and get on the bus and then drive over to the shuttle for launch. So these are how the students get involved as well. These are our CSIS astronauts. Bob, of course, in the middle, and the other astronauts were all Americans. And this is us in Russia doing some pre-flight collection for CSIS. And it's actually not Bob Thirsk in the box here, but that's Chris. Chris was the backup for Bob. And so he went through our experimental protocol back in 2009, as well as when we got him for the experiment for BPRIG and Vascular this time. Here's Bob up on the space station doing some of that exercise. He's also doing research. He's got a little cuff on his finger here that measures his blood pressure continuously. He's got this blue thing here is connected to the heart rate monitor that we used in our research. He's got activity monitors on his wrist and ankle. It's all part of the research that we were doing, as well as what one of the groups in Texas is doing here. The really neat thing about this email, or this picture, is it arrived in my email while Bob was still up on the space station. He sent it down to us from up there. And a couple days later, I walked into my office, the message light was flashing, picked it up. Hey, Richard, this is Bob. So, you do get some really interesting things happen when you get a chance to take part in space research. Why is Chris going to look so puffy today when he's up there? He's not going to look like this. That's his pre-flight picture, and this is one of the earlier press conferences that he did. Well, it's because gravity has an impact on where the fluids are distributed throughout your body. As I'm standing here right now, there's a lot of fluid down in the lower part of my body. I go into space, that fluid comes up and goes and makes you all puffy. Okay? So, and as well, what that's doing is it's modifying how the cardiovascular system has to respond on a day-to-day basis. So our research with the astronauts, clearly it's focused on astronaut health, but a lot of it has application to us back here on Earth as well. So these are the people who are involved in the Vascular experiment, and as I said, we're getting pretty close to the end of it. What Vascular is trying to do, I sort of sat in my office and thought, well, if they're being so inactive in space, if they float around basically for 23 hours a day, is that like being sedentary on Earth? We know that being sedentary on Earth causes blood vessels to change, and they get stiffer. They get stiffer as you age, but if you combine aging with sedentary lifestyles, they get a lot stiffer. Okay? So what we tried to do was ask the question, well, will they get stiffer with spaceflight? So we do a lot of ultrasound investigations to measure the properties of the blood vessels, and we're taking blood samples. You saw the picture earlier on where Chris was working with the Melfi, the -80 freezer. He's going to take some of his own blood for us, spin it down, put it into that freezer, and then it's going to come back. So our question is, can we find out why these blood vessels are getting stiffer? Because we did find out, these are some early results. Over on the left-hand side there, you see the results from our study. And remember, we proposed this back in 2004, and the Russians published some data in 2007 that shows that you do, in fact, see, this means that this downward slope here, it takes less time for the pulse wave to get from the heart out to the finger, okay, which means the blood vessels are stiffer. So we're finding pretty well the same thing in our astronauts that they found. But the thing is that we're doing those blood samples to try to figure out why. We're also, though, looking at different blood vessels. And this is Danielle and me in the lab here. Danielle holding the ultrasound probe and looking at the properties, how the artery expands. And I'm holding a pressure probe on the carotid artery on this side. And with those two measurements, we can then try to get an index of the stiffness or distensibility of the arteries. And these are some more preliminary data here. We see pretty well all of them have stiffer arteries in their necks after they come back from spaceflight. So this is the kind of image that Danielle gets for us to be able to pull out those data. Okay, so definitely these things are happening. It's supporting our hypothesis, and we're really looking forward to see what happens with those blood samples to try to figure out whether we can identify the mechanism. And if we can identify the mechanism there with astronauts, maybe it helps us understand what happens with aging as well here on Earth. As I said, blood samples. So this is one of our astronauts over in Russia having a blood sample taken. This is Jeff Williams, our first astronaut in the study, spinning the blood samples down. Katie Coleman, one of our astronauts, putting the blood samples into the -80 freezer. And then now they're coming back on the SpaceX capsule. So they splash down in the Pacific Ocean. They go from there to California and then down to Houston and then back up here to Waterloo. It's quite the process to get the samples from the space station to our lab here. Okay, and BPRIG, we're only just getting this started, but These are the guys who, Tom Marshburn is up there as well. So we've actually got 2 people doing BPRIG this flight. This is why. You can see this astronaut looks a little bit gray or a little green, perhaps. She fainted twice at a press conference the day after she got back. And this is the kind of thing that we want to try to understand. So what we're doing is, you can't stand up in space. But what you can do is put cuffs around the legs like this, keep them inflated for 3 minutes, let the pressure down really quickly, and what you see is this blood pressure tracing here. This is what happens on the ground before flight, or without flight. And this is what happens when you stand up. We don't have any data back yet, but we're thinking that if we see something like this, a bigger drop in pressure, those are the people who are going to be most likely to faint when they come back from space. Not everyone faints. Some of them, I've got a picture of one of those astronauts. He's standing there doing this, holding his 1-year-old daughter in his hands, less than 24 hours after he hit the Earth. There are huge differences in how people respond to space flight. So here I am in Houston in September. We're doing some baseline measurements on Chris. And I'm showing him how to put those leg cuffs on. Okay, so this is the training, so that when Chris is up in space, he's going to be able to do the experiments for us. So this is after the experiment. There's Danielle over here, and this is Andrew, who you'll see in a couple minutes, asking a question of Chris. And this is after we finished our experiments. So Chris now is all set up to be able to do the vascular experiment for us up in space and the BPRIG experiment. So he's going to take blood samples, and this is going to happen about 30 to 50 days before he comes back. He'll do it 2 different days, put them in the freezer, and we'll get them back in Waterloo. As well, he's going to put those leg cuffs around himself, have the finger blood pressure cuff on, and do that about 20 days or so before he comes back from space flight. And the idea here is, of course, for the astronauts, trying to predict who's most likely to experience problems with blood pressure regulation when they come back from space. Okay? So if we can identify the guys who are most at risk, we can then apply very specific countermeasures to try to help them out. Okay? So anyway, this is what we're doing with Chris. When he comes back, he lands May 15th or 14th, and he lands in Russia. They put him on a small Gulfstream jet. They fly him to Houston. The very next morning, he comes into the lab. He does a stand test for us and then does these ultrasound images. And we try to figure out how he has changed as a consequence of spaceflight and how well he did at exercising daily and being able to bring himself back healthy. Because we know from what we've done so far, exercise is absolutely critical, and exercise is absolutely critical for all of us in our daily lives. So we're looking forward to seeing Chris very soon. Thanks.
Thank you. Thank you very much, Richard. We're about 2 minutes from downlink, and so I'd like to take the opportunity to move directly into introducing our president, Dr. Feridun Hamdallapur, who will make contact with the International Space Station, Chris Hadfield. Feridun.
Thank you very much, Ian. Richard, Jeremy, Ian, ladies and gentlemen, welcome to the University of Waterloo. It's a great morning, it's a great day for the university, and a special welcome to all our students who are here physically and those who are watching us through webcast and other social media tools. It's a great day for the university because this doesn't happen every day. As you heard, Chris went up into the space in December. Lots have happened since then. The BlackBerry Z10 was born in between, and many other things have happened. I was here on this very stage a little over 2 years ago talking to Chris in person, who was here addressing our graduate students. He is a passionate person when it comes to research, when it comes to education, and he will give his entire time for this, and he uses every opportunity to talk to our students. And today we're going to see a very great example of this. I should also warn you that at any moment I could be interrupted when the signal comes. If I'm not, I'm asked to fill in the time, and I'm quite prepared to do this. I would love to tell you about shock waves and pressure waves and why all the glasses broke in Russia when the meteor hit the Earth. But University of Waterloo is the first university that Chris Hadfield is doing this. It's again because of various reasons, and you heard it from Professor Houston, the importance of linking what we do here on Earth and to many other things. And I could not think of a better example of linking research.
Houston, this is the International Space Station. We are ready for the event.
University of Waterloo, this is Mission Control in Houston, Texas. Please call the space station for a voice check.
Station, this is Feridun Handel at the University of Waterloo here with students. How do you hear me?
Dr. Hamdalapur, I read you loud and clear. Welcome on board the International Space Station. How do you hear me?
We read you loud and clear. I'm here with students. We're delighted to welcome you to the university.
This mic.
I can see him from here. We're delighted to welcome you to the university. We have a group of students who are anxious to ask you questions, so we'll just get on with it. Our first student.
Hi, Chris. My name is Rashmi Venkatesh. My question is, has the sensation of leaving Earth's protective field changed since your first trip into space? And can you describe your feelings, apprehension, wonder, or fear, as you left Earth's protective horizon on this mission?
Rashmi, I've been so fortunate to have flown in space not just once, but 3 times, and on different spaceships, and this time to be able to stay for months and months. I would say my apprehension was low. I was more concerned about not going to space than I was about going to space, because there are so many complexities in trying to safely leave Earth. I was also sort of the pilot of the Soyuz spaceship, and so a lot of eagerness to put all of that training into practice, to do all the things that so many people have prepared me to do. So it was with a great sense of buoyant energy and readiness that I left Earth's protective sheath, which is just outside that window, and launched up here to the space station a couple months ago. And I visited space twice before, but this time to live here, the richness of it, the ability and the time to absorb it and wonder about it and internalize it and think of it is magnificent. And so this is the difference between landing somewhere at an airport and taking off and getting off the plane and living there for a while. It's wonderful.
Hi, Chris. My name is Andrew Robertson. I'm fortunate to be involved in the University of Waterloo research that is examining the deconditioning effects of spaceflight that are similar to accelerated aging. My question is, can you tell us about some of the exercise and other countermeasures used throughout your mission which help to minimize these changes and prepare your body for a return to gravity?
Thanks, Andrew. There are, of course, as you well know in your studies, a lot of changes. Everything, some very obvious, the fluid shift, my extremely skinny calves that I have right now because of there's no gravity pushing the fluids into my legs. Some of them are very subtle. My eyes sting a little more up here because they don't drain ever. So you kind of have more a sheath of tears in your eyes more often. You can still cry in space, but the tears don't fall. And so there's subtle things as well. But the biggest ones, the ones we have to worry the most about, are preparing ourselves for coming home and preparing ourselves to be strong enough if we have to go outside and fix something. And as you mentioned, we use countermeasures. The two big ones we have are cardiovascular, and we have both a treadmill and an exercise bicycle. And those get our heart and lungs working and the blood coursing. And then the other is resistive exercise. And of course, you can do 10,000 push-ups up here because there's no up. But we have a device, a resistive exercise device, where you're pushing actually against big cylinders that if the air pulled out of them, like a vacuum. So you get a nice linear push against them. And it's a lot like lifting weights. And every single day we spend 2 hours on those pieces of equipment. The rest of it, we just float around. And you can be as lazy. I mean, I don't even have to hold up my head up here. But for 2 hours a day, we work hard. If I can get myself back down and, oh, I'm falling all over. I'm right up close. For 2 hours a day, we work hard to keep our bodies in shape, to keep our muscles strong, so that if we have to go outside on a walk, we can operate the spacesuit. And when we land back on Earth again, we'll be able to walk and our bones will be strong.
Hi, Chris. My name is Amber Nicholson. My question is, with your unique vantage point in space, are you able to see any evidence of environmental degradation on our planet?
Hi, Amber. We sure are. Some very visual examples like the Aral Sea, which because of irrigation changes, an entire inland sea has basically dried up to nothing. And from the first astronauts who flew and took pictures of it to us taking pictures of it now, the difference is striking. All the major cities of the world, the really big ones, normally are gray smears. The big city, Mexico City, LA, the cities in China, just because of the smog and pollution they create, and you hardly could even see them, and they have trouble looking up at the sky as a result. So you see that, and we also see the glaciers, and we've been taking a lot of pictures in Patagonia of the glaciers as they exist right now, and compare them to historic photographs. So and when there's a volcanic eruption and we look at the horizon, you can see the particulate in the upper atmosphere. So it's a wonderful vantage point for long-term monitoring of the Earth's atmosphere and the health of the planet on the surface, yes.
Hi Chris, my name is Sakshi Jain. My question is, in March you'll take on the responsibility of commanding the International Space Station. How are you preparing for this role, and how will you handle the stress that comes with the position?
Sakshi, stress is kind of a human emotion. It doesn't really come with a position. It's internal. And the way I try and avoid stress. And the way I avoid it is to try and never be in a position where I don't know what I'm doing or where I'm asked to do something I'm not qualified for. So in truth, I started training to command the space station when I was 14. I was in the Air Cadets and I went to a junior leaders course, and they taught me the basic precepts of leadership at 14 years old as a young Canadian. And since then, I've watched leaders, and you can learn something from every leader. You can learn a lot from the bad ones and a lot from the good ones. And I've also, through the military and then in my 20 years as an astronaut, been given increasing opportunities to manage and to lead people. And that all put me in a position where I could get assigned to command a spaceship. And now I've been training and preparing for that for about 4 or 5 years, working with the people on the ground and on the crew, preparing myself, thinking through everything that might happen, so that when the time comes, not only am I not stressed about it, but I'm eagerly looking forward to it. This is something I've really worked hard to be prepared for, an unprecedented opportunity personally and professionally and nationally. And I'm just really pleased that I'm in a position and really happy to have the chance to pick up the reins here in about a month.
Hi Chris, my name is Robert Henderson, and my question is, what is the most difficult experiment being conducted on the ISS during your mission, and what questions does it aim to answer?
We're running, I think, Robert, about 130 experiments on board. Difficulty is probably the ones that affect us personally. Some of the complex ones are running on their own. I set up and ran Robonaut today, and the alpha magnetic spectrometer is running. But one from the University of Waterloo, there's a Canadian experiment running down here in the corner that I'm taking care of. One from the University of Waterloo has some complexity to it. I think Dr. Houston was talking to you about it. But we take these leg cuffs, and I'm going to float the microphone. We take these leg cuffs and have to put them on our upper thighs here and get it all just right and attached, and then pump them up, and then when everything's just right, we have all the medical data attached to our body, then release them, and it's almost the same as coming from weightlessness and suddenly putting gravity back, so that the blood that was trapped now suddenly can flush down into the legs. And it takes a lot of setup, of course, to get all of the biomedical sensing equipment attached to our body, and then get all the parameters. I mean, Dr. Houston and his team have been working on it for years to get to the moment where I can get all this equipment set up, running properly in the right position, and then have my body go through this sudden change, so that then we can study how the body regulates blood pressure, how it regulates the blood flow, and use that, of course, for astronaut health, but also for the health of everybody on Earth who has blood pressure regulation problems. So one like this with a lot of equipment, they have a lot of complexity, but also they have a lot of benefit.
Hi, Chris. Hi, Chris. Hi, Chris. My name is Alex Lee, and my question is, how does internet work on the ISS?
It works really slowly, Alex, if at all. We don't really have internet, or just barely have internet on the space station, but we have multiple links to the ground. Some direct, just like a VHF radio. We have ham radio. But we also have high data rate communications through different bands of the spectrum, not just VHF, very high frequency, or UHF, but we also have S-band and KU band. Complex answer, but when we have KU band, it's a high enough data rate that we can bounce our signal off a geostationary satellite down to Earth, through all the ground relay sites, down to Mission Control in Houston, and then they take that signal and they hook it up to a computer that's sitting there like a mirror computer site down in Mission Control, so that when I tap on my keyboard up here, it goes through that long, long trail all the way down to that ghost computer on the ground, and that way I can access the internet. And that's how I can send messages on Twitter and do very slow functions. It's slower than dial-up, so I can't watch videos or anything, but it's good enough for just verbal and Twitter kind of data communication, and it's been a wonderful boon for me to be able to help communicate this experience to the ground.
Hi, Chris. My name is Michael Goldring. My question is, did the transition from test piloting fighter jets make spaceflight a less daunting task?
Yeah, astronauts come from a lot of different backgrounds. I was an engineer. Of course, I was an engineer at the University of Waterloo. I was a fighter pilot, and then I went to test pilot school, and I worked as a test pilot for several years. And an aerospace vehicle, just like the aerospace program that's at the University of Waterloo, trying to understand, if you make the engine twice as big or the wings twice as long or whatever, what happens? How's the vehicle work? How do you build a control system with all of the appropriate filtering so that a vehicle will have the right handling qualities? All of that has been directly applicable to flying the shuttle and to flying the Soyuz. And then the complexity of a big spaceship like this one, it's really just a super expanded version of some of the airplanes I flew as a test pilot. So I think for anyone who wants to fly in space, flying is a big part of that. There's all the technical side of it, but I think it was a very good grounding, if you can use that word, for what I'm doing now.
Hi, Chris. My name is Priyanka Patel. My question is, what feature on Earth's surface that's natural or man-made are you most surprised to be able to see?
Priyanka, the thing I was most surprised to see were noctilucent clouds. These are they're not right on the surface, but they're pretty close. They're the highest clouds that exist that you can see visually. You can barely ever see them from the ground. But if you get just the right angle between the sun and the earth, and they happen to be there, you can see them. And I thought I was going to have to be some sort of scientist or super photographer to be ever able to take a good picture of a noctilucent cloud. Some people think they're a good indication of climate change, as we can track the changes of these noctilucent clouds. But about a month ago, one night just coming up in Australia, they were as clear as a bell. And I grabbed a camera and used what training I had and got some, I was shocked. They were just so crystal clear, these ethereal clouds that normally are completely invisible, but that are a vital part of our Earth's upper atmosphere. And I managed to be able to see them with my own eyes and get clear pictures of them. And those pictures may well be one of the most enduring legacies of our time up here, is the science that comes along with that surprising thing I saw down close to the surface of the Earth.
Hi, Chris. My name is Nancy Soonteens. My question is, do you have any advice besides advanced education for those aspiring to become Canada's future astronauts?
Hi, Nancy. Yes. In fact, you should ask Jeremy after, because Jeremy asked me that same question about 14 years ago or 13 years ago. Number one is you need a healthy body, because we don't want to take a big risk on health up here. So not only, hopefully, you're born with a body that's healthy enough, but also you need to take care of it. So you don't have to go crazy, but exercise enough to stay in shape and don't eat bad things and keep your body in shape. Number two is an advanced education. And not so much for the education. I mean, a technical education is important, but to proven ability to learn complex things. And of course, you're doing that at the University of Waterloo, tremendous school. And then the third thing is an ability to make good decisions when consequences matter. And where the result of your decisions either is life or death, or big financial consequences, or something like that. And when Canada and all the other countries are choosing astronauts, that's what they're looking for. Very healthy people who have proven they can learn complex things at a high level, but who can also make good decisions when they have to. And then that just gets it down to 500 people or so. And then they're looking for all the other things. What else have you done interesting in your life? Other languages that you speak? What else do you bring to the table? Can you play guitar? Are you going to be an interesting person to go to Mars with or not? So, but you guys are on the right track. At the University of Waterloo, it's a premier school in Canada, and the things that you're doing and learning there are setting you on the right track, not only to fly in space, but setting you up for life.
Hi, Chris. My name is James Allen, and my question is, in your opinion, what is the greatest contribution that the International Space Station provides to the world, and is Asteroid Watch a part of that?
We'll be watching for the asteroid a little later today. We weren't in a position to see that meteorite do all that damage in Russia. It's going to be very hard to see the asteroid. They did the math, and it's going to be less than a pixel for us to take a picture. So we may, with a time lapse, see it go by. But for the space station itself, of course, with all the experiments going on, it's very hard to predict when an experiment will have a breakthrough. But I'm hoping that over its 20 or 30-year life of the station, from way back in in 98 when it was first launched, I'm hoping that there is some science that happens on here that is truly breakthrough. We sure are setting ourselves up for it. Mounted to the top is the alpha magnetic spectrometer, which is collecting matter and antimatter and high energy particles from the universe, trying to understand the fundament of what the universe is made of, studying the human physiology that you can't study on Earth when you take away gravity. But one of the main legacies may be that when one of you goes to Mars, you will be on a spaceship that has functioning pumps, is made of the right material, has a closed environmental system, recycling water and air, has all the systems that work. The hull is made of the right metal, all of those things because of what we learned here on the space station. When the first people sailed out of sight of land, it wasn't their first trip. They had sailed and learned how to build sailing ships, what oakum you needed, how the sails should be built, how do you keep people healthy on a long sailing voyage before they ever started leaving sight of land. And they owed their legacy to the early sailing ships. And for those of you that leave Earth to go somewhere else, you're going to owe your legacy to both the science and the engineering that is the International Space Station.
Hello, Chris. Ian McKenzie. I'd like to thank you on behalf of the University of Waterloo and particularly the students who participated in this event today, and we look forward to seeing you at the University of Waterloo in the future.
Dr. McKenzie, thank you very much. Thanks, everybody, for the great questions. Sorry if I didn't get to everyone's questions, but Jeremy's there, and he will be able to answer. Waterloo is a great school. My wife worked in Waterloo. I studied at the university. My son was born there. It's a great part of Canada, and I very much look forward to coming and visiting and really trying to take the time to tell you about this experience when I get back to Earth, landing in May and back to Canada this summer. So thank you very much. Thank you, Jeremy, and everybody for supporting, and we'll talk to you all later. Bye from the International Space Station.
Station, this is Houston ACR. That concludes the event. Thank you.
Okay, so we'll take some more questions.
Thank you.
That's pretty cool. I was thinking of a new experiment while I was watching Chris there. How many times do you think he's going to drop that microphone when he gets back to Earth? I think that's going to be pretty funny to watch to see if that happens. So I'm going to stand this far away from you for the benefit of the... Actually, I can stand over here for this, can I? So, yeah. All right, so let's take some questions. We've got, I think, about 20 more minutes.
Sure. Thanks, Jeremy. So my question is, due to Canada's unique geography and communications needs, space technologies have played a major role in Canadian development since the first artificial satellite since our first artificial satellite in 1962. Which space technologies do you think could play a major role for Canada's continued development in the coming decades?
Yeah, it's neat. I spent a lot of time pondering space technology and where I think the future in space exploration is going to go. Obviously, because it impacts my career, but I think it impacts our planet significantly. There's a couple of neat things. Obviously, robotics. So we know everyone's familiar with Canadarm and that niche technology that we've developed in Canada. We really are respected worldwide for the robotics that we've put in space. And we're doing really neat things. Recently, we did this robotic refueling mission where Dexter, which is the two-arm robot that goes on the end of Canadarm2, was doing an experiment on the International Space Station to see if you can successfully refuel a satellite in space without a human being being there to undo the nuts and to open up the valves and plug in and refuel a satellite. And a bowl of or a container of liquid or fuel doesn't act the same as it does here on Earth. On Earth, you put it here and you put your spout on the bottom, or you suck the fuel out of the bottom and that works. In space, how do you get all the fuel out of a container? What's the best shape and what's the best mechanism for doing that? So these are the types of things we're looking at, and Canada's been playing a part in those robotics, but it was a successful experiment. Dexter was able to do these dexterous tasks that human hands would normally do, and these satellites were not built to be refueled in space. We're just using the ports that they refueled them on Earth with. So that's one technology that I see Canada potentially being a part of in the future. We've also done a lot of work with rovers and remote technology. We use it in mining here in Canada as a spin-off from the space industry, but we're looking at how would we use those rovers and that technology on the surface of the moon, on asteroids, and of course on Mars. So those are some interesting technologies that I see Canada being a part of in the future. But I think it's worth mentioning that I personally see a shift in space happening right now. And a lot of people are talking about the doom and gloom of space and there's not enough happening, but I kind of see the opposite. I'm an optimist, obviously, but I kind of see we have commercial companies for the first time in the history of our planet investing lots of their own money into rockets and space technology and thinking that there's industry in space. And I think there is industry in space. And I always liken it back to aviation. Look at Canada. Aviation's just over 100 years old in Canada, and look how far we've come. Imagine the first people that saw the Silver Dart take off in Nova Scotia. They would imagine that you could get on an airliner and go anywhere in the world with 300 or 400 other people. You couldn't have even imagined. And those are the types of things we're now seeing commercial industry get involved in, which I think will change the map of how many people are flying in space. It won't be just Chris Hadfield flying in space for Canada anymore. It's going to be lots of Canadians flying in space, working in industry, and doing amazing things. And so I think we're just on the brink. We're just getting started with Canada exploring space.
Great. Thanks, Jeremy.
Hello, my name is Jacqueline Blacklock. I'm a PhD candidate in the Department of Recreation and Leisure Studies, and we know that work-life balance is important to quality of life. So my question is, how do astronauts achieve work-life balance while on mission, and what leisure activities could they engage in?
My first question to you is, were you speaking with my wife? This is a really great question, and I do remember asking Chris a question along those same lines many years ago, asking what the lifestyle of an astronaut was like, because I don't think I fully appreciated work-life balance back then, but I was kind of curious, is it compatible with having a wife, having a family, having kids? And of course, it turns out it is, but for me, raising kids, I have 3 children, twin 6-year-olds and an 8-year-old. Raising kids is the toughest challenge I've faced in my life. And so finding the balance between this very exciting job and a very important responsibility that I have of being a husband and a father is very challenging. But one that you just have to put the appropriate priority on. You just have to realize that if you decide to do those things, if you decide to get married, you decide to have children and have a career, you are going to have to find that work-life balance. And it turns out society, I find, is becoming more accepting of making those choices. People have realized, hey, you can't neglect your children and expect them to grow up to be contributing members of a Canadian society if you haven't put any effort in, you haven't given them a good example. And so society in general, I think, is realizing the benefit of making those career sacrifices to take care of your family. I don't find it all that, I find it extremely challenging, but I don't find that the external pressures are that great that will prevent you. I find all of the pressures come from within. And it's me that puts pressure on myself to be, at work or doing whatever needs to be done. And sometimes I need to pull myself back and say, hey, it's time to go sailing with the kids. So I think you asked what some specific activities were, but I don't have any activities in my life outside of work that don't involve 3 kids. Because there's just not enough time to do things for just myself. So if I want to have a hobby now, it has to involve my kids. And so we do family activities. So that my favorites are camping with the kids and sailing with the kids.
Nice. Thanks a lot.
Hi, Jeremy. My name is Edward Ringe. I'm working towards my Master of Quantitative Finance here at the University of Waterloo. And my question to Chris was that he's already for about 8 weeks on the ISS. And my question is whether his brain and body already truly adjusted to microgravity. So for instance, if someone would throw an apple to him, would he know where to put his hand, like here or here?
Yeah. So obviously, I'm a rookie astronaut. I haven't flown in space. So I haven't gone through the space adaptation period that the astronauts go through. But I've talked to a lot of people about it. And so I have anecdotal experience to share with you about what it's like for them. And I also watch them live and work in space. So when they first get there, and I noticed Chris flying through the space station with Kevin Ford, who'd already been there for a couple months. I noticed that Kevin Ford is more adapted, and he's making very tiny adjustments to his trajectory as he flies through the space station. He's very accurate. It's funny, I wish I could show you this on the stage, but unfortunately gravity is going to stop me. But he starts at one end of the module and pushes off, and you saw how narrow it is. There's not that much space. He pushes off in kind of this configuration as he translates across the station like this. And he goes all the way along the whole module, which would be basically almost the length of this stage, without ever touching a wall as he leaves one side. So he's become very adept at flying in the International Space Station. It's something else I noticed the other day. I was sitting in Capcom. Capcom's the person who talks to the space station. That was Jack Fisher, one of my classmates, who called us this morning to see if we could hear Chris. And sitting in that console, you spend a lot of your day watching what the astronauts are working on. And I noticed, they do different things where you and I would pick up an object and carry it somewhere. I was watching Tom, and he was flying through the station, and he stopped, he picked up an object, he put it between his legs, and then he continued on flying through the space station. So he just did the exact opposite of what we would do here on Earth. And so there is this period of space adaptation, And I think it's probably exponential. Initially, your learning curve is very steep, and then it slowly tapers off. And I'm sure it looks like Chris is very adapted to space. You know, he knows he can let go of the mic, and if he's careful about how he does it, it's going to stay within the capture volume of that microphone. So, does that answer your question, or were there any specifics I missed?
Good answer. Thank you.
Good.
Hi, Jeremy.
Hi.
I'm Dr. Farhan Aswar, and I'm completing a Master's of Public Health. My question is, living and working on the ISS can be really intense. So are there any mental health and cognition tests that are performed or any strategies employed to ensure the crew is functioning at optimal levels?
Yeah, absolutely. So this is something that affects not just astronauts, you know, obviously pilots, but every professional who works in a demanding field where your actions and your capability to perform matters. You know, if you're making mistakes, there's serious consequences on space station for making mistakes. And so we're definitely interested. And so we have this, let me see if I can remember the name. I think it's called self-reaction testing or self-reaction timer. It's basically, you see it in the astronaut schedule. I'm not sure if it's every day, but quite often it's in their schedule where they go and it's just this online, they have a computer, it's not online I guess, but it's on a computer and they basically take a self-reaction test where they get feedback right away. And of course the data is collected and so we're monitoring to see what are the effects on the astronauts when we sleep shift them, for example. So lots of times, you know, orbital mechanics are such that we can't make the SpaceX vehicle show up during the middle of their normal workday. We might have to have the SpaceX vehicle show up at, you know, what would be for you and I, our 2 o'clock in the morning when we would be normally dead asleep. So we've had to shift them. And so we want to know what the results of doing that to them are. So yeah, we are taking that very seriously because we've seen, there was an example of a Russian vehicle. It was a supply vehicle that was coming to dock with Space Station Mir. This was the old Russian space station. And the timing was bad, the crew was very tired, and everybody knew the crew was tired. And then something went wrong with the vehicle, and the Russian cosmonaut had to take manual control of the vehicle to dock it. And the vehicle ended up smashing into the space station and putting a hole in it. And it was a big deal, very dangerous. And everyone survived, but they lost part of the space station because of it. And I think it was a warning for them to say, hey, look, you know, human performance, this guy is a very gripped, capable individual. But you put him in a situation when he's absolutely exhausted, the human brain just cannot do what it can normally do. So it's a great question. It's one we're working on, and it's something that you could ponder for future experiments to give us some more insight.
Thank you.
And you know what's really important about those experiments, though, and it's important in everything, is that you do these things, we create an environment where this information is welcomed and understood and accepted, an accepting environment. So you don't want to put people in these situations and then test them and then judge them. You know, we have to realize that everyone is the same. We're all human. We all have human error and a tendency towards human error. And that's the culture we've developed in the space program. It's one we developed in aviation. And it's an important culture, an accepting culture, not a judging culture.
Hi, Jeremy. My name is Ryan Clement. My question is about, while Cold War competition initially stirred the formation of both the American and the Russian space programs, in this era of cooperation and tough economics, it seems support for space exploration might be waning. Where do you see space exploration going in the next few years?
Yeah, I think definitely the Cold War, I mean, the Apollo program, what a leap in technology. When I walk around the Johnson Space Center, which is where I work, and I see all the remnants of the Apollo program, you know, the old mission control, the Saturn V rocket. If you haven't seen a Saturn V rocket, it's just one of those things you need to do in your lifetime. I mean, it's amazing what was done with the technology they had. It still blows my mind to this day what was done during that time. And it was largely driven by fear and the Cold War. And we don't necessarily need those types of efforts, you know, a more I guess, level-headed, incremental step towards the future, I think is probably more appropriate for the world today. But we can accomplish some amazing things. And when I look at space exploration, my favorite things are when we realize how little we know about our universe. You know, if you look at some of the Hubble Space Telescope photos, I mean, they're absolutely magnificent. And what we actually truly understand about the mechanisms of how the universe was created and how it works and what's truly out there, I think really inspires me to keep looking over that next mountain to find out what's in the next valley. And I think that is what ultimately Chris is bringing back to us. He's giving us a perspective of, hey, you know, it's easy to get caught up in the everyday life of this, but it's going to change. Technology is going to move forward, or we're probably going to cease to exist on this planet in the future if we don't continue to evolve, continue to create technology that can support more humans on this planet. We're straining its resources. And I think that perspective and that drive to explore is what ultimately will continue to take us forward. And maybe a little bit of fear, like today with that asteroid that shot across the bow that said, hey, you know, the things we don't know can kill you. It's not news to a lot of people on the planet, but it'll be news to a lot of people who realize, well, maybe we should pay attention and continue to search.
Thank you.
Thank you, Jerry. We can take a few questions from the audience.
Yeah. So the question was, how does time work in space? So the astronauts, let me see, transition to Eastern Standard Time. I'll give you their day and our time. It's coordinated between all the agencies. I'm not sure how they came up on the exact line in the sand when the astronauts would get up. But the astronauts wake up at 1 o'clock a.m. Eastern Standard Time every day, on a normal day. And then they go to bed 16 hours later. And so, the time that we reference is Zulu time. So so what time is it Zulu right now? 17:35, so 5:35 in the afternoon. So the astronauts are at the end of, coming to the end of their workday. Yeah, how about right there?
First of all, I'd like to ask you to extend our congratulations to Dr. Hadfield and remind him of how proud all of us are of him and you and our whole CSA. And secondly, a lot of Earthlings have an issue with radiation and nuclear issues. What's being done? What can be done? What can we do as a humanity?
Mm-hmm. Which radiation issues specifically?
All of them, i.e.
Like space radiation or?
Stuff floating around in the ocean, North Korea, Iran.
Yeah. Okay, so the question was, first of all, it was a compliment to the Canadian Space Agency, so thank you very much. I'll pass that along to Chris, and we do appreciate that. And then the question was, what are we doing about radiation? Well, that's a pretty broad question to answer. I think there's an experiment that we're doing in space right now on neutron radiation, trying to understand the radiation in space. That's one example, and we're actually getting school kids involved in that experiment, where Chris has these little tubes. They're basically the size of a cigar tube. It's like a test tube, and it's filled with material that when it's bombarded by neutron radiation, a visible bubble is created, and then you just count the bubbles. And so we've given these same detectors to students on the ground to increase awareness to understanding radiation. And so they can do the same experiment and then compare their results to what Chris is getting in space to understand the protection that our planet provides to us living on Earth. If we didn't have the protection of the magnetosphere and of the atmosphere, we wouldn't survive here on this planet. And when Chris is off the planet, he's still protected by the magnetosphere, but if he leaves low Earth orbit and goes beyond, he won't even have that protection anymore. He would suffer significant amounts of radiation. So I think we're trying to pass along that awareness as well as enhance our own understanding. That program's Let's Talk Science, the one that's involving our students across the country. Obviously, radiation is hugely important to us going to Mars. So how are we going to protect astronauts on a journey to Mars? Now, your other part of your question, though, I think is much more probably pressing. What about the human-created radiation here on the planet? And I think that's a debate more than just, I can't answer it in a thumbnail. But I do think it's important. We do have to understand the effects we have on our planet and on the humans based on these types of things. I've heard some interesting theories too. I had a really fascinating conversation. Basically, I spent a day with a climatologist who was just explaining to us all the information he had on climate change. He wasn't saying yes or no. He just said, here's the facts. Here's what we really do know. You have to draw your own conclusions. But at the end of that day, he basically said, look, the data points to climate change. It's not succinct. It's not absolute. But it shows you that that's possible, that we could destroy our Earth. He said, and it's not going to happen tomorrow or next year. We've probably got about, on the order of half a century to really get control of this. But then if we didn't, we could destroy our planet in 300 years. And he said, you really have to decide whether you want to put some more effort into this or if you just want to take that risk. Maybe it is, maybe it's not. But for me, it kind of highlighted that's worth learning a little bit more about. And so I think that's probably a good place where we all should be at. We don't have to be alarmists. We don't have to destroy all of our economies and fix this tomorrow. But we should probably be paying attention and say, hey, let's have an open mind and continue to learn. Yes, right there. Yeah, that's a really pressing question today. So the question is, do we notice any changes in the human eye with respect to space travel? And we've only picked up on this in the last few years, and we have a very concerning change that we're noticing in the eyes of especially long-duration astronauts. And it's not understood yet. But basically, the shape of your eyeball is changing in space, and astronauts, they'll fly a number of different prescriptions of glasses for you because during your mission, your prescription is going to change based on the shape of the eyeball. But what's concerning is astronauts are coming back to space, and some eyeballs are going back to pretty much their previous vision, and some are not. Some people are living with a fairly significant degradation in their vision. And they're looking in a couple of areas. One is the intracranial pressure. So if you took I'm not a doctor, so bear with me here, but if you took your spinal column and your brain, it's all like a closed cylinder, or not cylinder, but container, and there's a certain pressure in there. And it looks like when you go to space, that pressure increases. That could put pressure on the eyeball, but there could be many other effects that could cause this. And some people's intracranial pressure is going back to normal when they come back, and some maybe not. So we're looking at that. It's a pretty interesting field and important to the astronauts.
Take one more question for Jeremy.
Okay. Who's got a really pressing question? How about all the way in the back? Yeah, so outside the station, if you went outside, yeah, it's not a good weather day out there. Of course, there's no pressure. There's no air to breathe. There's no pressure. So we always use that example. Your blood would boil, for example, because it would just boil off with no pressure. What about the temperature? Well, if you were in the middle of space with no effects of a star or anything, then it would be very cold, approaching absolute zero. But at the space station, we are always in and out of sun. So there are different materials will have different temperatures, but a very rough approximation would be if you were in the shadow, you could go from minus 250 degrees Celsius to plus 250 degrees Celsius in the sun. So when you're doing a spacewalk, if you pick up an object that's been soaking in the sun for 20 or 30 minutes, it can be quite warm. We have very thick gloves, but it can eventually start to be too warm or warm to the touch. And if you pick up something that's been in shadow for a long period of time, it'll be very cold. We have heaters in the gloves for astronauts who have to hold a big object for an extended period of time. So it's a pretty hostile environment. All right, well, thanks for all the questions. I enjoyed chatting with you today.
Thank you. Thanks very much, Jeremy. Thank you. At this point, I'd like to take the opportunity to thank the Canadian Space Agency and staff for the opportunity to do this downlink today, as well as NASA. And also, in particular, I'd like to thank the university, the students, and the downlink team that put this together. As many of you have already heard, Chris Hadfield isn't a stranger to the University of Waterloo. In fact, in 2007, he opened our aviation program here at the University of Waterloo. So as one of the questions that I had to Chris a couple of years ago was, how could we engage University of Waterloo students in space learning? And one of the options that came forward with the help of the Canadian Space Agency was this downlink event. And since Chris's launch just a few months ago, he's taken downlinks, social media, and space learning to a new height in Canada and the world. So as an end note to students, Technology allows you to peer over the shoulder of a scientist in a lab, an artist in a studio, and now an astronaut in space. Ideas start here. You are now engaged in space learning, and your classroom is the world and beyond. Thank you very much for joining us today.